Hello, everyone. Thanks for joining the anyLogistix Conference 2024. My name is Ali Yoguran, and I am one of the partners of Phoenix Analytics, together with my colleague, Emre Eryilmaz. And in this session, I will present to you a project we have done in Turkey for a multinational FMCG distribution company. And I hope you will get some insights about what we have done, what can be done with anyLogistix, and what kind of business value you can drive from using anyLogistix. So briefly, I will do a quick introduction about the problem and what we have done, and a few slides about the FMCG client itself, how their network looks. And then we will be talking about some business challenges that these kind of customers may be facing, and what kind of solutions we provided, and what we got out of this project. So this is a project in Turkey. It's for a multinational FMCG client. The challenges they were facing are twofold. One of them is that they are facing a lot of a high transportation cost. Turkey is a big geography, as you can imagine, and the railway network is not very sophisticated, so all of the transportation has to be done with trucks, with roads, which is quite costly. And anything you can save from transportation is a benefit. So that's one of the challenges this customer was facing. And the other challenge they were facing is that this is still a growing market for their products. So every year, a few percent, sometimes double-digit percent on some products, the sales is growing, the demand is growing, so they need to cope with this increasing demand, making investments, but making investments in the right place and in the right time. So we did a lot of strategic level analysis for this customer to help them to cope with this increasing demand while reducing the transportation costs. And we did a supply chain optimization. We built a digital twin, and we did a lots of mathematical, analytical analysis to answer these challenges. And the results were good, I would say. We ended up with around 10% cost saving on transportation, and we identified a few good optimal locations for the next investments. I will come to the details. So a few words about their supply chain. As you can see, this is quite a big network. They have 11 plants, which make about 250 SKUs at 50 production lines. So it's a lot of production capacity spread around the country at several locations. They deliver their products via their own distribution centers. They have 4 distribution centers, DCs, and they have around 200 distributors, which take the products and then distribute to the end customers. And they have some key accounts, like, for example, retailer chains, like big chains, and they make direct delivery to these end customers with their own fleet and from their DCs and from their plants. So the supply chain we are dealing with is this gray area, which is, I would say, quite complex and quite substantial. So what did we do? There were several business challenges, and we came up with several solutions to answer those challenges. Well, the first one is the sourcing matrix. This is probably the most fundamental thing you have to deal with if you are distributing to a wide geography, to hundreds of locations. It is about identifying the best source for your customer. Initially, this may sound simple because you may think, well, the best source is the closest source, and that's true. That's true, but it is not as simple as that, because there is no guarantee that you have enough production capacity the closest to the customer. Sometimes you may go to the next factory, next plant, if you don't have the right production capacity there. And also you have to make one full truck. So you have to bring together a mix of products to fill the truck efficiently. You cannot keep sending small trucks, half-filled trucks. You have to fill the truck with a mix of products. So you have to collect different products from different plants and send to the customer. To make life even more complex, sometimes the production cost of some plants, even if they are far away from the customer, may be lower. So sometimes it's maybe a better idea to send the products from a faraway plant if it has a better production cost than a closer factory. But you have to also consider the transportation cost. And you have to consider the inventory cost for product mixing. So when you put all these things together on top of each other, the problem doesn't look as simple as it sounds in the beginning. You have to do a lot of mathematical calculations to meet the demand of hundreds of customers by the production of a dozen of factories with all these cost numbers, transportation cost numbers, production cost numbers, and product mix for trucks. This is something we did. And of course, keep in mind that the demand is not always the same. Demand may be shifting, demand may be increasing, demand may be shifting from one customer to another from time to time. And you have to manage your production capacity as well to meet this shifting demand. So you open new shifts at some plants, you close some shifts, the lines are idle. And this is really a complex problem. anyLogistix solved this problem, and we compared it with the customer's Excel-based matrix, and we identified double-digit cost saving. So this is really a lot of money. I mean, if you do it right, if you do the right model, run it, if you balance the demand with the supply, it's a lot of saving. The next thing we did was investment decisions. As I said, this is a growing business, this is a growing market. And well, if you do the investment too early, you are losing your money, you are tying up your money too early. If you are late, you lose to your competitors. So you have to make the right investment in the right time and the right place. We did several years projections. We looked 5 years ahead, and we identified which products will have production capacity problems, and we identified the right place to make these new investments. And sometimes, even without the capacity problem, even the customer had enough capacity to produce the products, we looked at options of product diversification. For example, if a product is being made at 3 plants, we did scenarios like, what happens if we make this same product at a 4th plant, at 5th plant? Would that help? Would that reduce the transportation cost? Would that help us to solve this sourcing matrix problem at a more cost-efficient way? And we run lots of scenarios like this and identified some options, opening a new production line, new plant, or introducing new products to the existing lines. And lots of cost savings again. One other thing, this customer has seasonal products. at some months during the year, they have higher demand. At some months, they have lower demand. And sometimes it may be a very good idea to produce some products while you have capacity, while the demand is low, store them somewhere, and sell them when the demand is higher. But of course, this has costs because you are tying up your working capital. There's a financial cost, the holding cost. And of course, they have the shelf life issue. I mean, if you want to keep it too long in the storage, your products may perish. But there's a nice sweet spot there. You know, it's up to a point. It's a good idea to make stock within these constraints, and after that, it's not a good idea. So you have to stop there. And with just storing your products, you can save some investments, or you can postpone some investments, as I have explained here. Two other things: fleet management. They are hiring thousands of trips from 3PL vendors. If you know how many trips you will make between what source and destination, if you know your fleet requirement upfront early in the year, you can make a better negotiation with your 3PLs. And the 3PLs also feel more comfortable because they see they reduce the uncertainty. They may give you better prices. So if both sides have a good understanding of the fleet requirement, the destinations, so the 3PL may plan return trips, and it may give you better rates, you know, very fair. So this also produces some really valuable information for fleet management. After we designed this network, we built this digital twin, the supply chain digital twin, and started to play with some safety stock policies because, well, all these things I have shown you here are mathematical solutions, but real life sometimes doesn't work with mathematics. Real life has uncertainties. The demand may go up higher. You may have a problem at one of your factories. Your production may go down. So you have to buffer all these uncertainties with stocks. And we run several stock policies, like what happens if we have min-max policy with minimum 5-week stock, maximum 10-week stock, what is the consequences? Okay, your cost may go up, your customer service level may go up, or if you play with them, you try to find the optimal point for mitigating these kind of uncertainties in the supply chain. Even further, we introduced some additional uncertainties to the system, like production line decrease, demand fluctuations, and other things. And we assessed the supply chain resilience. You know, what happens with all these stock policies, this network, this sourcing matrix? How resilient is my supply chain, and what can we do? So this gives the customer the opportunity to look ahead, a few periods ahead, and take actions, take precautions, mitigate some of their risks in advance before risks become problems. So these were I would say, the key 6 challenges we solved with anyLogistix. Let me say a few words, a few sentences about how it worked and the architecture we introduced to the customer, where simply we got our data from Excel, and most of the Excel data came from SAP or their other operational systems. We did a few things with Python, I will explain in a minute. Fed them to anyLogistix and got the results again to Excel, to Power BI, or to Python again, and we did some analysis to make life easier for everyone, for the customer and for ourselves. At the moment, we are talking to customers to get rid of Excel and to get everything from their source systems. And the next thing, I think we will do that. We are talking to the customer about full integration at the moment. We did a few add-ons as Finance Analytics. One of them is customer clustering. This helps to boost the performance of analysis, because we did tens of dozens of scenarios, and sometimes you need to do it very quickly. And all we did is, like, for example, we combined all customers within 10 kilometers radius. I'm just making up the numbers just as an example, and treated them like one customer. By doing this, you are not losing any information, you are not losing any benefit, but you just make life easier. You just deal with simpler data, ALX runs faster, and you get simpler results, which meets the requirements of the customer. One other thing we did is we built this custom constraint builder at Python. anyLogistix provides you a custom constraint table, which is very useful. You can build in your business specific constraints here. For example, if you have a plant and this plant capacity is Q1, so your production quantities at these plants times their cycle times should not exceed Q1, and so on. You may have your specific constraints. I'm just talking about my customer. And we did this code, which just simply generates these constraints with one click. Normally, you can input all these constraints to the anyLogistix tables, or you can do that at Excel. You can write Excel macros, but we did it this way. It really helped us to speed up. We did one more add-on for analyzing the results. This is just an example. If you, for example, make an investment at plant A, you see how much production shifts from plant C, from plant B to A. So how your new network will look like, what's going to change. And of course, behind these tables, you have lots of other data. The transportation cost decreases from this to that. The production cost improves from this to that. The demand fulfillment changes and all that stuff. But we made these comparisons and scenario analysis quite easy. And these two helped us, or these three helped us to run many scenarios easily. Finally, this was a requirement from the customer, a dashboard for their production line utilization. So we kind of used anyLogistix as a master production planning tool to show you the future periods and how your production lines and efficiencies will look like. As a summary, we defined a sourcing matrix, a network structure which balances supply to demand, each period. We developed a master production plan, which also suggests shift plans for each plant, for each line. So they can take this data and plan how many workers they will need, kind of an SNOP at the aggregate level. You can plan your resources. We looked ahead, and see where the demand would not be met and what investments we would make. We delivered fleet requirements, we defined inventory strategies, and we developed some dashboards for the top management to see how their network will look like in the coming periods and in the current period. And we implemented some Python add-ons to facilitate this supply chain optimization and all these analysis. So that's all I can I can present you very briefly what we did, what the challenges were, and what we provided them. Let me look at the questions if I have any. Okay, what are the 10% savings based on? Yes, Linan, this saving is based on the baseline. The baseline means what they have done using Excel without any logistics. And we have their past transactions. We know their past actual sourcing metrics. And we did the same. We solved the same problem with anyLogistix, and the difference was around 10% cost saving on transportation. Gleb asks a question about the supply chain seems very extensive. What tools did you use? Well, we used Excel and Python. With Excel came the raw data. With Python, we kind of summarized it, clustered it, and we built these custom constraints. So it was Excel, but as I said earlier, we will switch to direct data transfer probably this year. Well, Linan, the 10% is ALX optimized versus baseline. If you do it without ALX, you get, let's say, 100. If you have done it the previous year with anyLogistix, you would get 90. So that is the difference. We solved the same problem we compared the anyLogistix solution against what they have done, and that was 10%. Well, did you get any issues when comparing the results from optimization? These two methods are very different from what the rest of the. Well, there is one question about whether the optimization and the simulation results were the same. They were not, because by optimizing their supply chain, we worked with monthly and in some cases quarterly periods, while we were aggregating the demand, aggregating the production capacity and everything. But in simulation, we did it daily. Life is daily, of course. I mean, customer may place an order every day, we send trucks every day, and there were differences. And those differences we solve at simulation, and we brought in stock policies, risk mitigation actions, and new stock policies. Well, there is one question about climate risk. Yes, in simulation module, you can define some risks, probability of those risks occurring. It may be a climate risk. It may be any risk. Your roads may be blocked. You may have bad weather conditions. You can build in all those risks into simulation. One more question about production fixed cost versus variable cost. Production cost is, we considered only variable cost, simply, because that's what counts for this customer. For the inventory, yes, I mean, Turkey is a high inflation country, and you have a holding cost for every product you keep in the store. We got those numbers from their financial team, and we put all those numbers. There's one question about how did you make your model operable for customer even if you're not there? Well, we trained the customer. I mean, we worked together with the customer. We collected the data, verified the results together, and then we provided training sessions for the customer. Now they have a few people who can use it, and even they are doing some of their analysis on their own now. So it worked quite well. Did you consider any fixed costs? Not for production costs, no. We considered only variable cost because fixed cost is sometimes misleading. We had this discussion with the customers. the depreciation cost, the investment cost, and all that, but it just blurs the picture. It's going for the variable cost seemed simpler for and understandable for all sides. Well, there's one question about what kind of constraints or dynamics within the chain cannot be simulated. Well, I cannot think of any that cannot be simulated. I mean, if you can model the constraints, there is a custom constraints table where you can define any constraint. I mean, any constraint you want. It's just a matter of how much effort you want to put in. But in our case, we modeled the storage capacity constraint, production capacity constraint, and shelf life constraint, and it worked fine, perfectly fine. If you have some other constraints, you can also model those. Well, there is one question about the baseline comparison from Santosh. Well, it's quite simple, actually. I mean, we got the data from last year, from previous year. We asked the customer, okay, which customer got from where? And they gave it. We calculated the cost, and we found a number. And then we said, okay, if that is your demand, we would do it this way with anyLogistix. And we came up with another cost. And we compared them. The difference was about 10%.